Hey guys, Elsa the Inequality Queen, back talking to you about compound inequalities. Now here's a question. Which Disney princess is a cow's favorite? That's Mulan!
First vocabulary term is a compound inequality. That's a mathematical sentence with two or more inequalities joined together with either and or. So a compound inequality means you're going to get two inequalities, and it's either going to be an and compound inequality or an or compound inequality. So let's start by talking about the and compound inequality. So the graph of a compound inequality with the word and demonstrates the overlap of the graphs of the two inequalities. Overlap or intersection of the two inequalities. So here we have x is greater than -7 and x is less than or equal to 10. Now, this is an and compound inequality, but and compound inequalities are not typically written like this. They're written like this. And now how did I get this from this? Our x is greater than -7. If I were to flip this, I would flip the entire inequality and I would get -7 is less than x. And x is less than or equal to 10. So instead of writing x twice, I could then just write -7 is less than x, which is less than or equal to 10. And it creates one compound inequality. And that is what we do when we have and compound inequalities. Now again, in and compound inequalities, we're looking for the overlap or the intersection. So when we graph it, what happens is we look at each of the endpoints separately. At -7, there's no equal sign. Therefore, we're going to put an open circle at -7. At 10, there is an equal sign. So we're going to put a closed circle at 10. And because we're looking for the overlap, we shade everything in between. That's an and compound inequality. An or compound inequality says the graph of a compound inequality with the word or contains the graphs of both inequalities. So there is no shorter way to write an or compound inequality. All you get are two inequalities with the word or in between them. Now what happens is when we graph this, we're going to graph each of them separately on the same number line. And it's going to look like two rays going in opposite directions. So here, x is less than or equal to -6. What I do is I put a closed circle at -6 because there's an equal sign here. And I want all x values less than or equal to -6. So I'm going to shade to the left. And since our variable's on the left, the inequality symbol, remember, points which direction we should shade. Same thing over here. X is greater than 3. Because there's no equal sign under here, I'm going to put an open circle at 3. And I want all x values greater than 3, so I shade to the right. And again, because our variable is on the left, our inequality symbol shows which way we should shade. Now let's talk about interval notation. That's a way of expressing an interval without using inequality signs. The numbers are the endpoints of the interval. Parentheses indicate an excluded endpoint, while brackets indicate an included endpoint. So think about it this way. If you see an equal sign underneath, that's going to be a bracket. If you see no equal sign underneath, that's going to be a parentheses. Now let's talk about how this works with and compound inequalities and or compound inequalities. For and compound inequalities, they're pretty easy to write. Now and compound inequalities typically look like this. And from this form, we can easily transition from inequalities to interval notation. Here, you can see there's no equal sign underneath this inequality symbol. Therefore, there's going to be an open circle at -7. It also means there's going to be a parenthesis when we use interval notation for -7. So it goes parentheses, -7, comma, and then for 10, since there is an equal sign, we're going to put a bracket, which indicates that that endpoint is included, which means there's going to be a closed circle there. That's how you do interval notation for an and compound inequality. For an or compound inequality, it's going to be a little bit trickier. You're going to do two separate intervals, and you're going to join them with this U. It stands for union. Now, because we have to do two separate intervals, we look at each of them separately. First, we have x is less than or equal to -6. That means we want all x values less than or equal to -6. So -6, -7, -8, -9, all the way to -infinity. So when we write this in interval notation, we're going to start at -infinity, and that's going to have a parenthesis right here because there's no point you can put on -infinity. So we have a parenthesis, then -infinity, comma, and it goes all the way up to -6, and -6 is included because we have an equal sign, which means we put a bracket instead of a parenthesis. Then it says or, so you put your U, stands for union. Then over here, we write our other interval for x is greater than 3. So we want all x greater than 3, so 4, 5, 6, 7, 8, all the way to infinity. So we're going to go from 3, put a parenthesis because there's no equal sign underneath, and then put comma, infinity. And again, we put a parenthesis because you can't put a point on infinity. Now this, in interval notation right here, is the same as this written as inequalities.
What does Mickey use to browse the web? An iPad mini!
Example 1. It says write each interval as an inequality, then graph the solution. So here we have the interval from -5 to 6, and -5 you see is included. So how do we do this? Well, if we're going to write it as an inequality, we first recognize that there is no union symbol in here, meaning that this is an and compound inequality. As an and compound inequality, it's very easy to translate between interval notation and inequalities. You start with your leftmost endpoint, -5, and since there's a bracket, it's going to be -5 is less than or equal to, then x, then 6 has a parenthesis. So you write -5 is less than or equal to x, which is less than 6. And again, 6, you can see, is not included, therefore it doesn't have an equal sign in here. We also need to graph this. So in order to graph this, we have our number line, and these are the easiest to graph. We go to -5 on our number line, and because there's an equal sign here, we're going to put a closed circle at -5. Then we go to 6 on our number line, and because there's no equal sign here, we put an open circle at 6, and since it's an and compound inequality, we're just going to shade everything in between. Here, see that we have a union symbol, meaning that this is going to be an or compound inequality. So what we're going to do is we're going to write two separate inequalities and just write or between them. So here we're going from -infinity to -1. That means we want all x values less than -1. But you see this bracket here? That means -1 is included. So we want all x values less than or equal to -1. Here we have from 3 to infinity. And you see how 3 is included? That means we want all x values greater than or equal to 3. Now again, because this is a union, that means this is an or compound inequality. Now when we graph this, it's going to be two separate inequalities. So we start with this one. X is less than or equal to -1. We put a closed circle at -1 because there's an equal sign down here. And since we want all x values less than or equal to -1, we want to choose -2, -3, -4, -5. All x's to the left. And again, since our variable's on left, our inequality symbol points in the direction we should shade. Here, we want all x values greater than or equal to 3. We put a closed circle at 3 because there's an equal sign down here, and we shade all x values greater than or equal to 3, so that'd be to the right. And again, since our variable is on the left, the inequality symbol points in the direction we should shade.
What did Daisy Duck say when she bought lipstick? Put it on my bill. You try.
For this first one, we see this union symbol. That means this is an or compound inequality. So we're going to do two separate inequalities. First, we're going from -infinity to -6. Now that means we want all x values less than -6. Now since this is a parentheses, there's no equal sign. So it is x is less than -6. Or, because there's a union symbol here, and then we have 8 to infinity. So we want all x values greater than 8. So 9, 10, 11, 12, all the way to infinity. So we want all x's greater than 8. And there's no equal sign because this is a parentheses as well. So we write x is less than -6. That represents this interval right here. Or x is greater than 8. That represents this interval right here. Now when we graph this, it's going to be two separate inequalities. So we start with this one. X is less than -6. So we put a open circle at -6 because there's no equal sign down here. And we want all x's less than -6. So that'd be -7, -8, -9, -10. All x's to the left of -6. And again, since our x value is on the left-hand side, our inequality symbol points in the direction we should shade. Here we have x is greater than 8. So we're going to put a open circle at 8 because there's no equal sign. And we want all x is greater than 8, so that'd be 9, 10, 11, so we shade to the right. Again, our variable's on the left, so our inequality symbol points in the direction we should shade. For part B, we have this interval right here, and you can tell that there's no union symbol here, so it's going to be an and compound inequality. So when we write this, it's going to be pretty easy to translate. We start with -10 is less than, because we have a parenthesis right here, x, which is less than or equal to, because we have a bracket, 1. Next, when we graph it, even easier. At -10, since there's no equal sign, we put an open circle at -10. And then at 1, since there's an equal sign here, we put a closed circle at 1. Since it's an and compound inequality, we shade in between, and we're done. Now example 2 says solve and graph each inequality. Write your answer as an inequality and in interval notation. So here you can see we have an and compound inequality. Now to solve this, I need to get x by itself in the middle right here. So we don't necessarily adhere to the simplify, move, solve deal here because there is no left and right. There's 3 spots. So here's what we're going to do. We're going to simplify first, just like we normally do. Can I simplify? No. Next, my variable has to stay in the middle. So then my constants need to go to the outside. Now here's how this works. I have 2x minus 5 in the middle. I need to get rid of the minus 5 and the 2. So let's first get rid of anything added or subtracted to my variable. So it's minus 5. What's the opposite of minus 5? I add 5. Now when I add 5 to the center, I must add 5 to both sides as well because this is a compound inequality. So now these are going to cancel each other out. That's why we did it. Over here, negative 7 plus 5 gives you negative 2 and 9 plus 5 gives you 14. Now again, I'm trying to get x by itself in here. So this is 2 times x. How do I get rid of the 2? I do the opposite, the inverse. I divide by 2. And if I divide by 2 here, I have to do it here and here as well. That way these cancel out, and negative 2 divided by 2 gives you negative 1. 14 divided by 2 gives you 7, and I'm done. How do we write that in interval notation? Again, these are really easy to translate. I start with negative 1, and since there's no equal sign in here, that's going to have a parenthesis. Then it's going to be comma, and then 7, and since there's an equal sign here, there's going to be a bracket. Now, anytime I have a compound inequality, I must check my answers. So here's how this works. I'm going to pick a number on this given interval. Let's say 4. 4 is an x value on my given interval, so I'm going to plug that in for x in my original inequality and see if it checks out. So what's 2 times 4? That's 8, and what's 8 minus 5? That's 3. Is negative 7 less than 3, which is less than or equal to 9? Yes. So because this checks out, we know that we got the right inequality. And when we graph this, we're going to put a open circle at negative 1 because there's a parenthesis here and there's no equal sign. We're also going to put a closed circle at 7 because there's an equal sign and a bracket. And because it's an and compound inequality, we shade in between and we're done.
What do you get when you cross Winnie the Pooh with a skunk? Winnie the P-U! You try.
Again, it's an and compound inequality, so we need to get r by itself in here. We simplify, just like we normally would, which we can't. We don't move any variables to the left or right because our variable needs to stay in the center. Our constants, though, have to go from the center to each of the endpoints. So how do I do this? Well, I start with anything added or subtracted to my variable. This plus 2 has to go. So the opposite of plus 2 would be minus 2. So I subtract 2 from the center, from the left, and from the right. Now these cancel each other out. That's why we did it. Over here, 2 minus 2 gives you 0, and 10 minus 2 gives you 8. 4, my last constant. How do I get rid of that? Since it's 4 times r, I do the opposite, the inverse. I divide by 4 here. And whatever I do to the middle, I have to do to both sides as well. These cancel out. That's why we did it. 0 divided by 4 gives you 0. 8 divided by 4 gives you 2. How do we write that in interval notation? It's really easy to go from an and compound inequality to interval notation. Since there's an equal sign here, I'm going to put a bracket and 0, comma, and then 2. And since there's an equal sign here, I put another bracket. Again, since it's a compound inequality, I must check my answer. So I pick a number on this given interval and plug it back into my original inequality. So what's a number on this interval? 1. Let's plug in 1 for our r. What's 4 times 1? 4. What's 4 plus 2? That's going to be 6. Now is 6 in between 2 and 10? Yes, it is. Therefore, this checks out and I can graph it. Again, to graph it, really easy. At 0, I'm going to put a closed circle because I have a bracket and an equal sign. At 2, I'm going to put a closed circle because I have a bracket and an equal sign. And because it's an and compound inequality, I'm going to shade in between and you're done. Okay, example 3, we're doing the same thing except here we now have an or compound inequality. This is kind of nice because for or compound inequalities, when you're solving them, you just solve each of these separately and then put an or in between them at the end and you're done. So let's solve this one first. Simplify, move, solve. Can we simplify either side? No. Next step, move our variable to the left. Done. Next step, constants need to go to the right. So this minus 1 and the 6 got to go over here. Start with anything added or subtracted to our variable. So this minus 1. What's the opposite of minus 1? That's plus 1. That'll cancel it out. Over here, negative 13 plus 1 gives you negative 12. And then to get this 6 over here, to get all my constants to the right, since it's 6 times y, I do the opposite, the inverse. I divide both sides by 6. That way these cancel each other out. And over here, negative 12 divided by 6 is going to be negative 2. Now again, why didn't I flip my inequality symbol? Because I'm not dividing by a negative number. I'm dividing into a negative number. That's different. Over here, same thing. Simplify, move, solve. Can I simplify either side? No. Next step, variables to the left. Done. Next step, constants need to go to the right. So this plus 6 and this 3 got to go to the right. Start with anything added or subtracted to my variable. So this plus 6, I move that over by subtracting 6 on both sides. That way these cancel out. And over here, 21 minus 6 gives you 15. Now I get rid of this 3. I move that to the right by dividing both sides by 3. That way these cancel each other out right here. And then over here, 15 divided by 3 is going to give you 5. Now I have my two inequalities. So I just write an or in between them and I'm done. Next, I need to write them in interval notation. notation. So here's how we do this. We start with this guy right here. Y is less than or equal to -2. That means I want all y values or all numbers less than or equal to -2. So -3, -4, -5, all the way to -infinity. So I'm going to go from -infinity, so parentheses, -infinity, comma, -2. Now do I put a bracket or a parentheses? Well, since there's an equal sign right here, I put a bracket. Then I put a u in between them because it's an or compound inequality. And over here, y is greater than or equal to 5. That means I want all y values greater than or equal to 5. So 5, 6, 7, 8, 9, 10, all the way to infinity. So I'm going to put a bracket because there's an equal sign here, then 5, comma, infinity, then parenthesis, because anytime you're dealing with infinity, that's going to have a parenthesis. Now, anytime you're dealing with compound inequalities, you got to check your answers. So let's check our answers. First, we start with this guy right here. What we're going to do is we are going to plug in a number on this given interval. So what's the number on this interval? Well, let's say -3. Yeah, -3 is less than or equal to -2, so we'll plug in -3 for y. Now we simplify. 6 times -3 is going to be -18, and -18 minus 1 is going to give you -19. Is that less than -13? Yes, it is, so that one checks out. Over here, the interval from 5 to infinity, what's a number on that given interval? Well, let's plug in 6. If we plug in 6 to the original inequality up here, 6 times 3 is going to give you 18. 18 plus 6 is going to be 24. Is that greater than or equal to 21? Yes, so those both check out. So now we know those are our correct answers. We can graph it. We can use either one of these to help us graph it. Let's use this one right here. Y is less than or equal to -2. At -2, we're going to put a closed circle because there's an equal sign here, and we want y values less than or equal to -2. So that'd be -3, -4, -5, -6. So we shade to the left. Again, since our variable is on the left, the inequality symbol points in the direction we're supposed to shade. Here, y is greater than or equal to 5. We put a closed circle at 5 because there's an equal sign down here, and we want y values greater than or equal to 5. So that'd be 6, 7, 8. Shade to the right. Again, our variable is on the left, so our inequality symbol points in the direction we're supposed to shade.
What does Ariel like to put on her toast? Marmalade! Marmalade. You try.
Again, we need to solve each of these separately, then put an or between them. So we start with this one. Simplify, move, solve. Can we simplify? No. Move our variables to the left. Done. How about moving our constants to the right? Well, we start by taking this 4 and moving it over here. How do I do that? Well, this is 4 times c, so what's the opposite of the inverse? We divide both sides by 4. That way these cancel out. We get c is less than or equal to 3. On this side, we need to get c by itself. So again, simplify, move, solve. Can we simplify? No. Move our variables to the left. Done. Next, move our constants to the right. So this 7 has to go. How do I do that? Well, it's +7, so I subtract 7 from both sides. That way these cancel out, and I get -c is going to be less than -6. Now to get c by itself, I need to get rid of this negative. So to get rid of that, I divide both sides by -1. That way, these negatives cancel each other out, and I get c over here. On this side, I get +6. And because I divided by a negative number, I must flip my sign. Now to finish, all I have to do is put an or in between these two inequalities, and I'm done. Next, let's write each of these in interval notation. Let's start with this guy. So I want all c values less than or equal to 3. So that'd be 3, 2, 1, 0, all the way to -infinity. So to write this, I'm going to go parenthesis, -infinity, comma, 3. And then because there's an equal sign here, I'm going to put a bracket on it. And then since there's an or, I put my union symbol. And then I go to this guy. C is greater than 6. So I want all numbers greater than 6. So 7, 8, 9, 10, 11, all the way to +infinity. So I start at 6, put a parenthesis because there's no equal sign, and then I go comma infinity. Then I put a parenthesis there because it's infinity. Now I check each of those. Take my original inequality and I plug in a number on that given interval that I found. So C is less than or equal to 3. I'm going to plug in, let's say 2. If I plug in 2 for C, 4 times 2 gives me 8, and is 8 less than or equal to 12? Yes, it is. That checks out. Over here, for this one, I take this initial inequality, and I plug in something in my solution set. So what would that be? Let's say 7, right? 7 is between 6 and infinity. So I plug that in. 7 minus 7 gives you 0. Is 0 less than 1? Yes, it is. So these check out, which means I can graph it. At 3, I'm going to put a closed circle. So I go to 3, put a closed circle because there's an equal sign here. And I want all C values less than or equal to 3. So I shade to the left. That's all values less than or equal to 3. Again, since my variable is on the left, my inequality symbol points in the direction I'm supposed to shade. Same thing here. C is greater than 6. So I put a open circle at 6 because there's no equal sign here. And I shade all the numbers to the right of 6 because those are all the numbers greater than 6. Again, variable on the left, inequality symbol points in the direction I'm supposed to shade. Example 4 says solve and graph each inequality. So we're doing the same thing. Here you can see this is an and compound inequality. The only difference here is that now my middle section is all divided by a number. How do I get rid of a fraction? Well, we said anytime you want to get rid of a fraction in an inequality or an equation, you multiply everything by the least common denominator. Since there's only one denominator, multiply everything by 3. The reason we do this is these 3's now are going to cancel each other out, and I'm left with 3 times negative 2 over here, which is negative 6, and 3 times 2 over here, which is positive 6. Sweet! Now it's super easy. To get q by itself, I got to get rid of anything added or subtracted to it first. So this 4 has to go. Since it's positive 4, I subtract 4 from the middle and from each of the endpoints here. Now these cancel each other out. Negative 6 minus 4, the same thing as negative 6 plus negative 4, so that'd be negative 10. Over here, 6 minus 4 gives you 2. Now I just have negative q in here. How do I get rid of this negative? Well, I need to divide by negative 1. Since it's negative 1 times q, I do the opposite, the inverse. I divide by negative 1. And then when I do that, I have to divide everything by negative 1. So these are going to cancel each other out, which is sweet. But look, I just divided by negative 1 in a compound inequality. How is that any different? It's not. You still have to flip the signs. You just flip all of the signs. So it looks something like this now. But we never write our and compound inequalities like this. So what I'm going to do is flip this entire compound inequality. Here's what's going to happen. I'm going to put the negative 2 over here. Then I'm going to put less than or equal to. I flip this sign, and then q. And then I put less than. I'm going to flip this sign and put 10 on this side. So it's going to look like this. I just flipped everything. Now I have my compound inequality, so I can write that in interval notation. How do I do that? I start with negative 2. And since there's equal sign, I put a bracket, then negative 2, then a comma, and then 10. And now do I put a bracket or a parentheses? Well, there's no equal sign, so I put a parenthesis. Now check your answer. Let's pick a number on this given interval. How about 1? We plug in 1 for q into our original inequality, and we simplify it. What's 4 minus 1? That's 3. What's 3 divided by 3? That's 1. Is 1 in between negative 2 and 2? Yes, it is. Therefore, this checks out, and we can graph it. So at negative 2, because there's a bracket and there's an equal sign right here, we're going to put a closed circle at negative 2. Because there's a parenthesis and no equal sign, we're going to put an open circle at 10. And since it's an and compound inequality, we just shade between those two endpoints. Okay, let's talk about a special case. So we're doing the same thing here. We have an or compound inequality, so we're going to solve each of them separately. First, simplify, move, solve. Can we simplify? No. Next, move our variable left. Done. Next, constants need to go to the right. So this minus 1 has to go. Do the opposite, the inverse. I add 1 to both sides. That way these cancel out. And over here, 1 plus 1 gives you 2. So I have a is less than 2. Over here, a plus 7 is less than 12. So I'm going to simplify, move, solve. Can I simplify? No. Next step, move variable left. Done. Constants need to go to the right. So this plus 7 has to go to the right. So I do the opposite, the inverse. I subtract 7 on both sides. That way these cancel out and I get a is less than 5. Now I put an or between them and I'm done. After that, I need to write it in interval notation. So for this first one, it's going to be a is less than 2. So I want all the numbers less than 2. So 1, 0, negative 1, negative 2, all the way to negative infinity. So I'm going to put parenthesis and then negative infinity, comma 2. And then since 2 doesn't have an equal sign right here under the inequality symbol, I'm going to put a parenthesis again. Then I'm going to put an or. I put a u for my union symbol. And then for this one, a is less than 5. I want all the values less than 5. So 4, 3, 2, 1, all the way to negative infinity. So I put parenthesis, negative infinity, comma, and then 5. Since there's no equal sign, I put another parenthesis. Right away, you should see that something doesn't look right. We have a negative infinity here and a negative infinity here. That's kind of weird. Well, let's check our answers. So we start with our first inequality here, and we plug in a value that's on the given interval that we solve for. So what's less than 2? How about 0? We'll plug in 0 for a. What's 0 minus 1? That's negative 1. Is negative 1 less than 1? Yes, it is. Therefore, we can say that that checks out. Let's try the other one. A plus 7 is less than 12. Let's plug in a number on that given interval. How about an a value less than 5? So let's say 4. If I plug in 4 for a, what's 4 plus 7? That's going to be 11. Is 11 less than 12? Yes, it is. So therefore, that checks out as well. Okay, cool. Now let's graph it. A is less than 2. So I'm going to put an open circle at 2. And I shade all the values of a less than 2 because our variable's on the left. You can see our inequality symbol points in the direction we're supposed to shade. Or now we're going to graph a is less than 5. So at 5, we're going to put an open circle. And we want all a values less than 5. So we shade to the left, all the a values less than 5. Oh, well, that's weird. I just shaded over my other line. So what that means is that a is less than 5 overlaps with this a is less than 2. Now, because it's an or, we want the combination of both. We don't want the intersection. We want the combination of both. We want both of them to be on our graph. So what we end up doing is just saying, okay, we're not worried about the a is less than 2 because the a is less than 5 takes care of that. So a is less than 5 ends up being our only answer here.
Why does Alice ask so many questions? Because she's in Wonderland. You try.
Okay, same thing here. Simplify, move, solve for both of these. So we simplify, nope. Next step, move variables to the left. Done. Constants need to go to the right. So I'm going to add 3 to both sides. That way these cancel each other out. And I get m is greater than, over here, 1. Same thing over here. I add 9 to both sides. That way these cancel out. And I get m is greater than or equal to 4. Now I put an or between them, and I have my inequality. After that, I need to write that in interval notation. So m is greater than or equal to 1. That means I want 1, 2, 3, 4, all the way to infinity. So I'm going to start with 1, put a bracket because there's an equal sign, and then comma, positive infinity. Then I'm going to put a u for my union symbol, for my or, and then m is greater than or equal to 4. So I want 4, 5, 6, all the way to infinity. So I start with 4, a bracket because there's an equal sign, and then comma, infinity, parenthesis. Now this should look kind of weird, like the other one did, because I have 2 positive infinities. Well, let's check our answers. So we start with our first inequality, and we plug in a number on that given interval that we found, so m greater than or equal to 1. Let's plug in 2. 2 minus 3 is going to give you -1, and is -1 greater than or equal to -2? Yes, it is. Sweet, that one checks out. Now let's check the other inequality. So m minus 9 is greater than or equal to -5. Using my solution set that I found, I'm going to plug in an m greater than or equal to 4, so how about 5? 5 minus 9 gives you -4, and is -4 greater than or equal to -5? Yes, it is. That checks out. So let's graph these. Let's start with m is greater than or equal to 1. I'm going to put a closed circle at 1 because I have an equal sign here, and I want all m's greater than or equal to 1, so that'd be 2, 3, 4, so I shade to the right. Same thing here. M is greater than or equal to 4. So I'm going to put a closed circle at 4. And I want all m's greater than or equal to 4. So I shade to the right. 5, 6, 7. These overlap. So what do I do? Well, because it's an or compound inequality, it means that we're going to keep both of these graphs on our graph. We want both of them. Meaning that this m greater than or equal to 4 is basically useless. It's meaningless because we already have m greater than or equal to 1. So we don't need that. We just need m is greater than or equal to 1. That takes care of the m greater than or equal to 4. Word problem says the acidity of the water in a swimming pool is considered normal if the average of 3 pH readings is between 7.2 and 7.8 inclusive. The first 2 readings for the swimming pool are 7.4 and 7.9. What possible values for the third reading will make the average pH normal? First, word problem. We're not scared. Second, what is it asking? It's asking what possible values for the third reading will make the average pH normal. So the third reading, okay, step 3, that makes defining our variable easy. We're going to say the third reading is going to be R. Next, what we do, we need to write our equation. So what other information are we given? Well, we're given that the average of 3 pH readings is between 7.2 and 7.8 inclusive. That means that we're going to create a compound inequality, and it's going to be an and compound inequality where 7.2 is going to be on one side and 7.8 is going to be on the other side because we got to be in between that. And it's inclusive, so it's going to be 7.2 is less than or equal to whatever the average of the 3 readings is, which is less than or equal to 7.8. Now, what do I write in the middle? Well, I need the average of the 3 readings. So how do I write that? Well, the first 2 readings are 7.4 and 7.9. So I'm going to do 7.4 plus 7.9 plus our third reading, all divided by 3. That would be the average of our 3 readings. Now I have this inequality. All I have to do is solve it for R in the middle. So what we do is we need to get rid of this fraction. Since it's divided by 3, I'm going to do the opposite, the inverse. I'm going to multiply everything by 3 because whatever I do in the middle, I have to do to the outer endpoints as well. So I multiply everything by 3. 3 times 7.2 over here gives me 21.6. 3 times 7.8 over here gives me 23.4. And then in the middle, these 3's cancel out. That's why I did it. Now I have no more fractions. Now what I can do is in the middle, I need to combine the 7.4 and the 7.9 and I get 15.5. Then to get R all by itself, I get rid of this by subtracting 15.5 from each side. These cancel out in the middle, and then over here, I end up getting 6.3. On this side, I get 8.1. So R is in between 6.3 and 8.1 inclusive. So that means 6.3 is less than or equal to R, which is less than or equal to 8.1. Now, what does this mean? Well, first, let's check. Does this answer make sense? So if I were to plug in a value in here, let's say 7. If I plug in 7 for R, do I get an average that is between 7.2 and 7.8? Well, let's simplify this in our numerator and and then divide it by 3, I get 7.43 repeating. Is that between 7.2 and 7.8? Yes, it is, so that checks out, meaning that this is our answer. But don't leave this as your answer. You were asked a question, what possible values for the third reading will make the average pH normal? That would mean the third pH reading must be between 6.3 and 8.1 inclusive because of these equal signs. And you're done.